Okay, this video here we'll look at a brick detail at a upper floor scenario, so pretty much right here or right there, or in this case right there, I guess too. Okay, so I'll just give a start here, explaining, orientating what I've drawn here. So I've assumed a steel structure, so here's a finished ceiling on the inside. Here's an open web steel joist, the steel beam, composite floor system, so concrete on a metal deck. And again, I've gone with some outside insulation. There's the brick right there. And it's a semi-bypass stud system. So there's the stud right there and right there. And what you see in the purple right here is some added steel that's going to support the shelf angle out here. So it's not recommended that that shelf angle be attached to the edge angle, as it'll twist. So your engineer might take a different approach to this, but generally what can happen here is HSS tube can be put right here, in between the joist seats basically, and then you could have some steel HSS tubes spanning back and get welded to the top of the beam. I don't have a picture of that, exact condition, but it'd be, just imagine, I guess this is the top of a steel beam right here, and it'd be something kind of like this, where it has some HSS tubes, being welded to the top of the beam and then extending out to pick up the knife plate and the shelf angle. And in case you didn't see my earlier video, then this again, this is the knife plate scenario with a shelf angle, steel L angle welded to that knife plate, which is then in the case that I've drawn, that knife plate would be welded back to this HSS right here. And so I don't have a picture of this on steel construction necessarily with the exact scenario, but it looks something like this. So this is obviously a stair core or something like that. Stair elevator core there, and then at every level they're putting in a steel angles because it's gonna hold some masonry up of some sort. So you can see the knife plates going back and the shelf angle on the outside, and you can tell that it's at every level there. So anyways, I've drawn all that steel in purple there just so it's easier to see. So the joist seat would be extended in this case probably as well, and it would be back here, but all that tube work is hiding it basically. That's why we're not seeing it there. And so I guess the first thing to talk about is, well, why do we have a shelf angle at every floor level, like we've seen in the last couple of pictures there? And again, I talked about this in the first video or at the briquette foundation, but the idea is there's a couple of reasons for this. One, you don't want to stack too many bricks in height, or else the axial load of the brick gets to be too much at the bottom of the bricks. Basically, would be one thing. You could go more than one floor though, and I think you can go up to like 2 floors safely. But generally, what happens is there is a support angle at every floor usually, that then transfers the loads back to the superstructure. The other reason this is a good idea too is remember that we designed this cavity behind the brick so that there might be water in that cavity or moisture in there. It might be on the face of the insulation, it might be on the back of the brick. There might even be some back here, on the moisture barrier there, the air vapor moisture barrier in this case. So you don't want all that accumulating. Like say you have a multi-story building, you don't want all that moisture accumulating at the very bottom of the brick wall, or you just have more of it to deal with at the bottom. It could be problematic. So the idea here is to get everything out of the system at every floor. Another bonus to this as well is by putting shelf angles, this is a continuous shelf angle, that purple right there that continues all the way along. So you've created compartments in the brick, so you've compartmentalized 2 zones of the air cavity behind the brick, which helps with pressure equalization around the wall, because you get different pressures at different areas of the wall, so it actually helps with that in that perspective as well. And so the only other thing that I've shown here that I didn't show in the previous video was I've shown the brick ties in here. So these are just the ties that are there's a plate that comes out from the it's attached to the stud basically in the wall, and there's a plate that goes through the insulation, and then there's like a pin. There's various types of these brick ties, but they're just holding the bricks up laterally so they don't fall over like that. So I've shown a couple of those. They have to be located in certain locations. I'd have to dig up some specs to figure out what exactly the spacing is of these things from the floor and from each other and so on and so forth. But just to give you an idea, of what they are. This is kind of what it is I've drawn. So I've drawn a dashed line for the plate that's coming out. So the insulation will go around this, and then there's a pin that goes into this slot right here that lays into the mortar of the brick. So that's a brick tie system being roughed in basically. It's not complete yet there. And so basically what it would look like, the pin looks like that. It lays into the mortar of the brick. So anyways, I've just drawn those in just so it's not forgotten that those things do actually exist. So I've just indicated those that way. Okay, so something else of importance I've got here is a deflection track right there. Okay, and so what this is, when there's loads on this floor, this beam here will actually deflect. So, in elevation, that beam would be like this. So we might assume that it's, here's our columns, let's say like that. You might assume that beam is perfectly flat, but actually once there's a load on it, and of course, depending on how far it's spanning too, it will, I'll just exaggerate it, but it will do that. It'll deflect down like that, basically. So we got to make an allowance for that. So engineers will usually design the structures to L over 240 or L over 360, I think it is. And that's just the span divided by that number. And that gives you an idea how much the deflection would be. From my experience, it's rarely more than 25 millimeters, let's say. But again, it depends on the span, how big the grid spans are. So anyways, I've just shown that here. So that's a very important item to indicate in your detail. And I'll show what that looks like in the stud view, or what it is exactly, and then I'll explain why there's a gap in the sheathing there, and why that caulk joint is there, and what this extra membrane is right there. So that's all related basically. And if I zoom in on this, a stud wall right here, so this is an infill stud wall, but studs are going in between the steel, and if I zoom in up here, you'll see a track right here with some slots in it. So that's the top track, and basically what happens is the stud gets installed into that track, but it doesn't go the full height, like it's down a little bit. And what that does is when the structure deflects, that track can slide up and down without putting pressure. It just slides up and down right here at this joint. It doesn't put pressure, obviously, on the stud and bow it and then crack your walls and all kinds of stuff. So that's called the deflection track. So it's very common, it's just kind of used everywhere as a top track for a lot of stud walls. And so that's what I've drawn right here, basically, those lines there, and then again that the vertical stud just slides into that track, basically, and there's a gap left there. Okay, so I've highlighted a bunch of stuff here, and basically everything that's highlighted in red there will move. So when this beam right here deflects, okay, so when it goes down, pretty much everything's attached to that beam. So everything in the highlighted area is going to go down with it, and then back up when the loads are taken off, for example. So that has to be taken into account, and again, so if all this stuff in the red there is going to move down, then we're going to have to put a joint in the sheathing right there, right? So the sheathing above would be attached right there, and then the sheathing below could be attached right there. And when this sheathing slides down, you don't want it crushing this sheathing down here, or again, you're going to get some problems right there. Same goes for the brick. So the brick angle is going to say flex down, and you don't want it crushing. You don't want a hard mortar joint there, or you're going to get cracking in the brick or whatnot, right? So so what you do there is a foam rod sealant right there. You could leave the gap open, but then insects can get in there. So usually you want to put a foam rod and sealant in there. And then when it flexes down, It just, just squishes that basically, and it doesn't squish the brick. So that's the whole idea there. And that's an important thing to address in all your details as to where deflection is going to occur, and then make accommodations for it. Now, I've drawn the air vapor moisture barrier on here, so there it is there below, and over that, it's a pretty flexible membrane, but it could just be there could just be a little bit of slack put in the membrane at that deflection joint so that it doesn't tear basically. There's also some I guess some reinforcing strips that could be put on there as well. So that's kind of what I've indicated right there. That's just a little bit more flexible and can deal with that deflection joint. But basically, if you show it where the deflection is, then the suppliers of the self and installers of the self-adhering membranes will accommodate that basically with their membranes. So just like the briquette foundation video, we've put our air vapor moisture barrier on here there. I've put in that reinforcing strip there. I've made sure there's a positive overlap there. Then I've put in another membrane right here which overlaps that one, and then of course I brought down the one from the wall above. It overlaps that strip right there and then overlaps the flashing like so. So you want to make sure you have all those overlaps, and again that's an important overlap there to ensure air continuity in the membrane. I should just back up here a little bit. So we talked about how we want to get moisture out of this system right here. So that means we need weep holes here as well. So that's what the X there in the brick is representing, the weep holes. And then of course, because there's another compartment below, that's the vent hole at the top for the compartment below. So again, there's vent holes at the top of each compartment and weep holes at the bottom, and that allows air circulation through the cavity to dry it out, and it also allows, obviously the weep holes allow moisture to weep out of there. So the next thing I want to pay attention to here is this detailing, what we're seeing right there. So there's a couple of approaches, actually there's a few approaches to how you can deal with that situation right there, because what you end up with is a larger joint there, so it's quite visible. And we saw that in the intro picture that I had of that brick wall. And so there it is there. Okay, so that's it's a very obvious joint there because it's quite large. Now in this case, I can't zoom in any closer to that. It almost appears to me that they didn't put a cock joint in there, but anyways, that's their choice, I guess. Again, it's okay, except you could get insects getting in there because again, the weep holes there and the vent holes here on the underside, you can see them there. They have screens in them basically so that insects don't make nests in the cavity of the wall. So, but this is a good picture of for seeing the weep holes and vent holes. So the shelf angle there, so I can see all the weep holes on the top of the shelf angle, and then I can see all the, well, it's harder on that one, all the vent holes on the bottom here, and then weep holes on the top of the shelf angle there and there, and so on and so forth. Here's a picture on the same building where actually I got a little bit closer here, but yeah, you can see there's the weep holes, there's the vent holes, and you can see the steel of that steel shelf angle there. And again, it looks like there might be some sealant under there. It's hard to tell. But anyways, that's a pretty common approach. Like what you see in that picture there is very, very common. That it's a very visible, defined line in brick, and that it's just accepted that way. So that's what I've drawn here in this detail. Okay, so the orange there is the metal flashing going through the insulation. So right here is the metal flashing, and that's just going to take the moisture out like that. Now, one other approach to this, and probably the more proper approach from certainly a building science perspective, with drip edges and stuff, is to, and the reason I left this orange that far from the shelf angle there is because what could happen here, I mean, this could be a continuous piece of flashing, but there also could be another layer of flashing that it's overlapping. And you could do something like this. Okay, so you can have another piece of flashing in there with a nice drip edge on there so that when moisture is coming out of that cavity, it's not, if that flashing wasn't there, moisture could come out of this cavity and it would start to run down the face of the brick. And you could run into problems with that brick having too much moisture on there. You might get efflorescence or something like that. I mean, typically you don't have a lot of moisture coming out of that brick in our part of the world anyways, because we're quite dry here. But certainly, I suppose if I was in a wetter environment, I would probably really consider putting that flashing in. But you just got to be careful with that, because that, obviously, when you stand out here and look up at this building, you've just brought more attention to that joint there, and so that just becomes a decision of do you really want to see that flashing there? So I would say, from walking around the city of Calgary, I would say 9 times out of 10, I see it like this. Okay, and I can't say that I've noticed any issues with, again, it's fairly dry here, so I haven't noticed any issues here with efflorescence forming on the underside of those shelf angles. But there is another approach, and I would say it's kind of the 1 time out of 10. It's probably the better approach, but again, does it affect, is it acceptable from the aesthetics of the building? So I'll show an example of that. This is actually in the same neighborhood as the other one, but if we zoom in, where the shelf angles are occurring on this building, so they've done a stack bond on this building. You can see they've done the metal flashing. Okay, so I can see it very clearly right there. So they've put the flashing in with the drip edge, which is a really good detail. But it obviously pronounces those horizontal lines more, which in this case I can tell that's what they wanted, right? Like, they've actually used a colored flashing that's much darker than the brick, so that you can see it really well. And so I suppose, again, this I would say is a much better approach to this. So maybe it's a good idea to work that into the design if you're doing a brick building. So I'm going to leave it there because I like it. But yeah, other than that, that's pretty much all it is. That's a pretty typical standard detail. Now, I'll just leave this video by saying that, if there was, say, a window right here, and maybe I'll do a video for this at some point, but if there was a window right here, and let's just say there was a window right here, then you wouldn't have to put that shelf angle there. That shelf angle would just be at the window head, basically. Okay, so you just bring some steel down like this or something like that to pick that up, and again, you need some steel for the window probably to sit on as well. So if you had a continuous kind of window, not even continuous, but if you had windows, I guess primarily below, we'll talk about, then that shelf angle could just be moved down to the window head, so that you don't get 2 shelf angles, basically. Like, there's no point in having it if you had a shelf angle here, because there's going to be a window right here. There's no point in having a shelf angle there and there. You might as well just get rid of this one and just do that one, because you're not adding that many more bricks to the weight of that angle, basically. So that's the only thing I'll say with that. You just have to look at your situation and decide what happens there. So I guess what I'm saying is, this isn't the be-all end-all. I mean, I'm just showing one example here of what we saw in the picture, basically, probably. But it could be different depending on the situation of the building. And so here's an example of that right here. So in this picture right here, the floor level would be right here. So the structure of the floor would be roughly right there. Okay, and there's obviously no shelf angle. Quite obvious, there's no shelf angle there. So what they've done is they've got a window head down here. So they've just said, okay, well, we'll just do a continuous. You can see it there. We'll just do a continuous shelf angle here, because we need to do one over the window head anyways to get the load of the brick around the window. So yeah, they've just, you can see it there. They just decided to put it there and continue it all the way across, rather than put one here and then have one here. So that's exactly what I was just kind of getting at. It's a good example of that. So again, just look at your situation and see what makes sense, and lay out that shelf angle where it needs to be and show it in the elevation, because it will be a prominent line one way or the other. You will see it. Oh, the other last thing I should mention too is there is a way to kind of hide that joint a little bit. Obviously, if you're doing the flashing, that's not going to work. But so if we just go to the Brick Industry Association, this is American, but it's fine. There is something called a lip brick, and let's just see if we can find a detail of this. Okay, I'm just going to go to their technical notes. 18A has it here. So let's just go to 18A. And they've got some details of exactly what I've kind of just drawn here. You know, here's the shelf angle. And the idea is that they've shown the flashing with the drip edge on the outside and the soft compressible material underneath the shelf angle, and they put an X through there for the weep hole and so on and so forth. But if you go down to here, these are the lip brick details. So, you know, you have to check with the brick that's been chosen, obviously, for the building, if they have a lip brick for it, or I guess it could be cut custom for it. But, you know, you can do this where there's a little lip basically right there that just hides the face of the angle. Okay, you still need to do the, you know, the soft joint below the angle for the deflection, but that will lessen the visibility of that joint a little bit. So that is an option. I don't like this one just because this one here, you know, if the sealant was, let's just say you didn't do the flashing and the sealant was getting worn, now you're collecting water in there. So this seems to be a better approach to do it that way. So I don't see a lot of that, but, you know, that is an option that someone could play with. But anyways, this video provides some basics for you to get started. So that's kind of the, you know, the bulk of it right there. Have fun detailing.